So today we're in section 4.2, slope of a line. But the first thing I want to do, and I want to make sure that this is in the recording also, is review 4.1. So on Wednesday, you have a quiz over 4.1 and 4.2. All right? And this is really important for your quiz. This is really important. It's going to be at least 10 points on your quiz on Wednesday to graph the linear equation. And all it does is it gives you an equation. Y equals 4x minus 3. Write it down on your notes. Y equals 4x minus 3. But what do you have to have in order to graph? What do you have to have? Coordinates. X and Y. Ordered pairs. And it does not give you. It doesn't give you any ordered pairs. So guess what you have to do? You've got to figure out the ordered pairs. Well, how in the world do you go about doing that? You can't just make them up. You have to figure out what values for X you want to use. All right? And you can use, you should be writing these down as I'm talking, but you can use any value you want. Okay? I want that to really sink in with you. You could use any X value you want and plug it into that equation. Y equals 4x minus 3. But why wouldn't I use, say, 50 for my X value? Why would I not want to use a 50 for my X value? Mason?
You have to make your coordinate plane much larger.
Yeah, that makes your graph really large. Even if you use large intervals, you still have to graph a graph that is much larger than necessary. So that's why we say we want to keep our X values really close to 0, but we have to have a negative and we have to have a positive. Okay? So it doesn't have to be these exact numbers to be correct. Okay? But this is what we call our standard set of numbers. If the number connected to X is a whole number, which it is, okay, I'm going to use my standard domain set, and that's -2, 0, and 2. Now, if the number connected to my X is a fraction, I have to take a different approach, okay, but it's not. It's a whole number, so I can use my standard domain set, and domain set is basically just my X values. So what do I do with my X values? What do I do with that? -2, 0, and 2. What do I do with that, Elizabeth?
Plug it in.
Plug it in where?
X.
Yeah, in for X in my equation. So 4 times -2 minus 3. 4 times 0 minus 3. 4 times 2 minus 3. Go ahead and make those substitutions, and whatever the answer is, that's what you're going to write in your Y. Okay, so what is 4 times -2 minus 3?
-11.
-11. What is 4 times 0 minus 3? -3. 4 times 0 is 0. Okay, and then what's 4 times 2 minus 3? 5. Okay, but I still don't have ordered pairs. Or do I? Do I have an ordered pair? Okay, what's my first ordered pair? -2, -11. What's my second ordered pair?
0 and -3.
0, -3. What's my third ordered pair?
5.
Okay, so 2, 5. So now I want you to visualize. I'm going to kind of extend this graph down a little bit, and sometimes it doesn't quite fit on the graph, and that's okay. We're just going to kind of extend it down. All right, I want you to visualize where this first point would go. Just kind of pinpoint it with your eyes on the screen. All right. And are you kind of picturing it to be right about there?
Yes.
All right. Do the same thing with the second point. Again, we're not actually graphing these on our papers just because this is supposed to be a review and we don't want to take too long. All right. So did you visualize about there?
Yeah.
Okay. And do the same thing with your last point. And was it about there?
Yes.
Okay. So now this might seem like a small detail, but my graph is not complete. What do I still need on this graph of the line? What do I still need? Does anybody kind of notice something that might be missing based on 4.1? Ethan? No, the unfilled box we don't need. Mason? Nope. The arrows.
Oh, I was
The arrows. Were you thinking that? Okay, so it's a really, yeah, it's a really small detail, right? It's a really small detail, but what do the arrows mean? Just tell me.
It goes on.
That it keeps going, okay? So here's what I need you to understand about linear equations. Now, a linear equation is a straight line when it's graphed, okay? That's all that it means, all right? But the arrows mean not necessarily that the line goes on forever, but that there are infinite solutions to the equation, all right? Now, I'm just going to show you another random point on this line and how it ties back into the equation. Does everybody agree that this point right here is pretty dead on basically where the line intersects that point? Okay? So what is the ordered pair that matches that point? It's, yeah, -1, -7. Okay, so now let's work this backwards. All right, so basically I graphed it, but now I want to show you that at any point where the line intersects on this graph, that point is also a solution. So does everybody agree -1 is my x value, right? That's the x value on the ordered pair. So what's 4 times -1? -4. What's -4 minus 3? -7, which ironically is also my y value in the ordered pair. And guys, that's going to be true for any ordered pair that this line intersects. So you see, there are infinite solutions that make the equation true, and I'm showing that on my graph. All right, do you understand that? That those 3 values are not the only solutions to that linear equation. There's actually an infinite number of solutions. All right, so here's what you're going to have to do on a quiz and test. You're going to have to come up with your own table and graph it. The graph will be given, the template will be given to you. It's going to look just like that. You come up with your own table of values, and then you graph it. And when is that quiz? Wednesday. Okay, today's Monday. Your quiz is Wednesday. That's a big part of your quiz. Okay, so now moving into 4.2. All right, the slope. Actually, let me go back real quick. I want to show you one other thing. Real quick. So this is what we're doing in 4.2. All right, look at the line on that graph. From left to right, is it sloping up or down? From left to right, it's sloping up. So I would say that this has a positive slope. So from left to right, if it was going down, what would I say about the slope? It's negative. So the slope of a line, guys, is basically how much it's angled, okay? And that's what we're examining today. All right, so let's talk terms for a second. The formula is critically important, okay? Without the formula, if I only have ordered pairs, I have to graph everything. How many people would say, yeah, if I had the choice, I would want to graph every single problem? All right, you would probably say no, because graphing is extremely time-consuming, okay? So if there's a shortcut to where I only have the ordered pairs, but I can find the slope some other way other than viewing it on a graph, I want to use that. Well, my formula is my shortcut. All right, you also need to know that an undefined slope occurs when 0 is in the denominator. 0 is your denominator value. A slope of 0 occurs when 0 is in the numerator. All right, you're going to see that in just a second. And parallel lines have the same slope, which we probably will not have time to cover today, and we'll cover that tomorrow. Okay, so in example 1, I'm finding the slope of a line. Okay, so first of all, you need a line. Again, this is not something you have to graph on your notes, but obviously it's important in us figuring out what the slope is going to be. All right, so here's your line. All right. And the arrows, again, mean that there are infinite solutions. So now, instead of focusing on graphing the line, which is what we did in 4.1, now we're looking specifically at the slope. So describe the slope of the line. That means, is it positive or negative? So again, we read these lines from left to right. Is it sloping up or down? Up, so it's positive. That's all you have to do is say positive. Okay? And now, since we conveniently have a graph here, we are going to use the formula rise over run. Rise over run is the formula that we can use when we have a graph to read the slope. Okay? So let's think about this practically. When you rise, what direction are you going? Up and down or left and right? When you rise. When you rise, you're moving in an up or a down motion. So that's your Y value. When you run, you are moving across, left to right. So run is your X value. All right, so that's important, that your rise is your Y value and your run is your X value. Your change in your Y over your change in your X from left to right. So that's the important part here, is that you're moving in the correct direction. Okay? All right, so from the first point to the second point, how many units do you rise? Well, you go 1, 2, 3, 4, 5. You rise 5. So 5 is the value that goes in your numerator. Okay, you see that? All right, so maybe I'll make that a little darker so you can see it. All right, you went up 5. And how many did you run? 1, 2, 3, 4, 5, 6. You run 6, so 6 goes in your denominator. And that's your answer. That's all you have to do for your homework. Okay, positive or negative, and then do your rise over your run value. There is another way that you could find slope. Now, this way would be what we would consider the long way when we're looking at a graph, because reading rise over run on a graph doesn't even involve any math, okay? So if you're a chance for a mistake, this is definitely the method we want to use. However, I want to show you the other method so you see how they line up and give you the same answer, okay? And that is by using ordered pairs. So the first thing we have to do is figure out the ordered pairs that stand for each point, okay? And I'm just going to give them to you, all right? Okay, so -3, -1. Here's why, though. You got to understand this. I went left 3, down 1 for my first point. Okay, so that's the ordered pair that represents that point. Are you with me? So I'm pulling out the ordered pairs that represent the points. All right, so this one's 3, 4. Why? Because it goes over to an X value of 3 and up to a Y value of 4. Are you seeing that? Okay, so pull out the ordered pairs. Write them on your notes. Okay, write the ordered pair on your notes. -3, -1, and 3, 4. And it's very important that you write it in the correct order. How did I know which ordered pair came first? It's left to right. The point that's farthest to the left, that ordered pair comes first when I'm listing them. That's very important. Otherwise, you're going to get your slope backwards. Okay? So now I have to figure out, how am I going to get from these ordered pairs and plug in the values in the correct location? Well, I have to figure out which value is going to be Y2, which one's Y1, and here's how I do it. There's a specific sequence, and this sequence never changes. On your homework tonight, I want you to label your ordered pairs the same way. X1, Y1, X2, Y2. We know that an ordered pair is made up of XY. So we're basically saying in the first ordered pair, it's X1, Y1. And in the second ordered pair, it's X2, Y2. Again, this sequence never changes. And when it comes time for your quiz and your test, guys, you're not even going to have to write that because you're going to have it memorized. By the time you get to the end of your homework tonight, you will probably have that sequence memorized and you won't even need to write it anymore. Okay? But here's why I want you to write it. You paying attention? I want you to write the sequence because it helps you memorize which value is which. That I have it labeled, which value is my Y2 value? 4. Okay, right? That's the 4 is the one that matches up. Now, this is very important. The subtraction sign is part of the formula. What is my Y1 value? So now I plug in a -1 also. And I have a double negative, okay? So don't think, oh, well, there's already a negative there, so it replaces it. It doesn't. Now it becomes a double negative, and you're going to see that over and over again. Homework, quiz, and test, when you plug in a negative value, now that becomes a double negative. Divided by, what's my x2 value? 3 minus, what's my x1 value? -3. So now I have double negatives, top and bottom, which both turn into a positive, okay? And I have 5/6. So again, we did this on example 1, not because it was necessary. When I have a graph, just use rise over run. But I want to show you that if you use the formula, you can find the exact same slope. And it is faster when you don't have a graph to read, and you're going to see that in a minute. All right, second time should make more sense than the first time. All right, so here's our second one. All right, now we have another line. What do you notice first about the slope? It's negative because it's sloping down to the right from one point to the next. It's negative. Okay, so we do notice that it's a negative slope. And because we have a graph to read, and this is very similar to some of your questions on your homework, we're going to use rise over run. But before we do that, I want you to pull out the ordered pairs that match these 2 points. Okay, so just read the graph. What is the ordered pair that matches this point and this point? Read the graph and write it on your paper. Okay, we're going to pull out the ordered pairs. So I want to practice pulling out the ordered pairs and labeling them, x1, y1, x2, y2. But then we're going to use rise over run to solve it. Okay, because again, when I have a graph, there's no sense in me doing all the hassle of the formula when I can just count rise over run. So what's my first ordered pair? -1, 1. What's my second ordered pair? 2, -2. Okay, don't get your signs mixed up, guys. So I heard some signs mixed up in that. Make sure you're getting your signs correct. So now let's label them. x1, say it with me, y1, x2, y2. Okay, so that's very important that we understand each one. We are not going to take it any further with the formula. Could I, though? Could I plug it into the formula? Absolutely. Again, though, it's not necessary because I can simply read rise over run. Here's what I want you to remember, though. We've already indicated that our slope is negative. Our run will never be negative. I just move left to right. What is negative? Our rise. Because now from left to right, from this first point to the second point, my rise is going down. Okay? So go ahead and write down the fraction that would represent this slope. Okay? So count your rise over your run, at least as best you can. I know you have to look at the screen. Okay, so what's my rise? -3, and what's my run? Close. It's 3 again. Okay, and again, guys, your run will never be negative. I have to take off if you make your run negative. When you're moving left to right, you're never moving negative. Okay, so that's important. Can I reduce -3 over 3? Yeah, I can. It's -1. Don't change improper to a mixed number, though. Okay, but you can reduce or simplify. All right, so now let's move on to example 2. Finally, that was like the longest example 1, I know. So in example 2, we're talking about exceptions to the rule. So 9 times out of 10, there's going to be some kind of slope. But every once in a while, we see exceptions to that with horizontal and vertical lines. All right, so here we're still going to use the rise over run method, guys. Okay, again, the graph is given to us, so why not take advantage of the fact that I can see 2 points on the graph? All right, now from one point to the next, is there a change in the y value at all? From one point to the next, do you see a change in the y value at all? No, you don't. So the rise is 0. From one point to the next, from left to right, the y value does not change between the points. Do you see that? The points are on the exact same y value. But it does run, okay, so from one point to the next, it moves to the right 7 units, all right? But my rule says anytime 0 is involved in the slope, I have to take it one step further, and there's a rule for this. If 0 is in my numerator, meaning it's a horizontal line, you wrote it down in your terms. What does that say about the slope? If 0 is in the numerator. Slope is 0. I wrote a line through it just to clarify that's a 0. Okay? So if 0 is in my numerator, that means it's a horizontal line and my slope is 0. That's something you have to have memorized. Okay? So, again, horizontal line, slope is 0. So what if it's a vertical line? If it's a vertical line, again, guys, the fraction's important. The 0 over 7, if you don't write that in your homework or quiz or test, I'm going to take off partial credit because that's kind of like your proof, all right, why your slope is 0. So let's look at vertical line, all right? On a vertical line, now there's a change in your y, right? You go from a y value of what on top? A y value of what? What's the first y value on top? Guys, look. 6. It's on a y value of 6 up here. You see how it matches up with the 6? Okay. Down to a y value of what? 2. So you went down how many units? 4. But did your x value change at all between the 2 points? So what happens when you have 0 in your denominator? It's undefined, okay? And anytime you have a vertical line, guys, your slope is undefined. Okay? Anytime you have a vertical line, your slope will be undefined. So you have 2 exceptions. If it's a horizontal line, your slope is 0. You show that in your fraction, okay, with 0 in the numerator. If it's a vertical line, your slope is undefined, meaning 0 is in your denominator. There's no movement on the x-axis. Okay? All right, so those are your 2 exceptions. The last thing we need to cover today is how do you find slope when all you're given are ordered pairs? How do you find slope when all you're given are ordered pairs? And here we go on example 4. Write down these 2 ordered pairs and label them. So on your homework tonight, whenever you're given the ordered pairs, I want you to label them x1, y1, x2, y2. Again, that's just getting us in the habit of these x1 values, okay, and which one's which. Okay, so again, we need to label our values. All right, so we know which value gets plugged into our formula. All right, so we have x1, y1, and we have x2, y2. Did everybody label your values just like that? Everybody label them? Okay, so which number plugs in for y2? 2. Which one plugs in for y1? Hold on, which one? -1. That's your y1 value. So there's already a subtraction sign in the formula, and now you're plugging in a -1, so there goes your double negative, okay? And like I said, you guys are going to see that over and over again. All right, so that's important that you catch that double negative. Now, what's your x2 value?
6.
And what's your x1 value?
1.
So it's minus a +1, so it's just a -1. All right, again, what happens to your double negative? Becomes a positive. Okay, so 3 over 5 is your slope. 6 minus 1 is 5. All right, go ahead and now do the second one, and we'll be done. Okay, did everybody label your ordered pairs?
Yes.
Josh, did you label your ordered pairs? X1, Y1, X2, Y2. Logan, did you do it? Okay, so now let's plug them in. Which one is your Y2 value?
-3.
-3. Which one is your Y1 value?
-3.
minus negative 3. Okay, so the subtraction is already in your formula, and y1 is negative 3. Okay, what's x2? 5. And what's x1? 2. Okay, so what happens, guys? What happens to my double negative here? What? What happens to my double negative? What happens to my double negative? It becomes a positive. Okay, what's negative 3 plus 3? 0. And what's 5 minus 2? 3. Okay, so you don't know that it's a horizontal line until you get to this point. This is not your answer. Anytime 0 is in the fraction at all for slope, you have to take it one step further and say slope 0. Slope is 0. Or if 0 was in your denominator, what would you say? Undefined. Slope is undefined. Okay? And if you understand that, that's everything you need to know for section 4.2.